You've really got to get back to clean metal at all. The last time you saw this casing, I was grinding away where the threads had been damaged, where the casting had actually been burst away. It welded up quite nicely. Unfortunately, all the arc shots I took were badly out of focus. I forgot to lock my camera, so I can't show them. So that's enough of the video I can't show. Let's do some of the video I can show. I've used a milling cutter and I've milled these flat, and now like a fanny's hair, probably 1.5 thou above there. They'll be finished off with a sheet of sort of 180 emery paper on a surface plate. What I need to do now is pick up the 2 centres and drill and tap those holes. Quarter BSF the thread was. This is the template that we made, which goes on here somewhere. And it goes like that. So I can pick up these four bolt holes and then mark through there and drill and tap those. That one there's got no threads in, it's just a hole. That one's threaded. As is that one. And that one. Right, so that's a good fit. There's no movement on it, a very little movement on it, so we're trying to pick those 2 holes up. What I'm going to use to pick those up is a 1/4 dowel. I'll run a 1/4 dowel pin or a 6mm dowel pin in a chuck. Just find the dead centre of that and then drill and tap each one in turn. I need to find out how deep they were, so I'll take this back off and just measure the depth. I know they're in quite a long way. Looking at that, probably 25 to 30mm, because we've built it up solid with weld. That's the shallowest one. I'll measure that and then we'll go from there. 25 to the bottom of there. So if we drill them both, 24, that's going to give us plenty of thread. Temp it back on. Oh, John. Right, that's it. At least we have now got metal under there. Right, I've got a nice 1/4 inch roll pin in the chuck, so I can use that to line up this hole. Just eyeballing it, you can get very accurate indeed by using the eyeball method. Starting to get somewhere near there now. In fact, that looks pretty good. Right, so we'll do the first one there, centre drill, then I'll drill it for the 1/4 BSP, 1/4 BSF, and then tap it. Right, centre drill first. That's right in the middle of that hole. .3 is the tap and drill for 1/4 BSF. That drill's a 5.2, so I'll have to we'll lock that off there, and I'm going to reset the 0 on the DRO and use that to drill it 24mm. A little bit of WD-40. There's the dreaded noise. Great, 24mm. Not sure how good this top is. I can use the jog buttons on the machine to top it. Right. Bloody hell, man. Right, we've certainly got some threads in there now. And they look decent as well. That looks good, looks really good. That's right in the middle. Sorry, I'll take that cardboard off here to see what's going on. Right, once again 24mm. Really grip it, but not too tight to the point it wants to be able to slip. I'd rather it slip in the chuck and snap the top. Yeah, quite pleased with that, decent repair. I might want a little bit dressed down the other diagram, but I don't think so. Just want this face rubbing flat and that'll live again. I've been asked by one of my viewers if I can make him a spanner to fit this collar chuck he's made for his Mayfad lathe. The spanner's 45.4mm across, so I would make a one probably 44mm plasma cut from 10 or 12mm steel, and then you can file or grind it to size. This is the CAD drone program that comes with the plasma table. I'm not going to draw it, I'm going to go into here, into file, new, and that is various shapes that are pre-made, and all you've got to do is change bowl toolers or dimensions or whatever you want. But there's quite a lot of stuff in here. If you want a quick part, you can probably find something in here you can modify. So I'll go down, click on wrench, except it's not a wrench, it's a spanner. We call them spanners. It's already set at 44.5. It will be simple enough to change it to any size you want, say 67. But we're going to leave it at 44, and you've got a little bit to play with. The length 254, that's about right, and the material I'm going to use 12mm. Okay, that's a spanner there. You get a 3D view of it. You can do somersaults with it, make it sick if you want to. I'm not just going to leave it at that. I think I may do a little bit more. I think I'll put my initials in it just to show how you can basically put lettering in. We'll click on that little box there. I'll put in DB for double boost. Make it a decent sort of size, something like that. Bring it along to the end where it's not going to affect the strength of the spanner anyway. Right, so we need to convert those letters into some of the plasma and cut. Cross here, click auto, and it automatically changes those into some of the can be plasma cut. You click on here, there's loads and loads of different fonts. There's literally thousands of fonts. You can download fonts off the internet, but this is the one I know works and I quite like it. Right, so now if we click on the pyramid, it's asking me to convert the text. You just convert it, just do what it says. Okay, right, so there's the spanner with my initials all the way through it. I like it. Right, so we need to save that. We need to export it. DFX file. I'm going to call it DB 44 spanner. Right, I'm just going to save it on the desktop. Export. Okay, I've opened a program called SheetCam. SheetCam comes pre-installed in the software package with the plasma table. This is where you convert your DFX files into a G-code, which enables them to be cut, where you set all the parameters to cut past what material you're cutting. Right, so we'll click on File, click Import Drone. We need to go into Desktop, and the drone was called DB44 spanner. That's it there. So you click on that, open, click OK. Right, that's the spanner with my initials on. Right, so we need to set up how we're going to cut it. So click on here. Right, I need to select the material, and I'm going to use 12mm. So what we've got here is 1/2 inch steel, that one there. There's various rules you can alter in here. There's loads of different things that you can change parameters, you can change different things. It's quite intimidating at first, but once you get into it, it's not that bad. I'm just going to leave it set the way it is for the minute, and we'll see what sort of result we'll get. Okay, so we're happy with that. I'm going to change the lead in to tangent from perpendicular. Okay. Right, so it's actually showing there how it's going to cut it. It's obviously going to cut them out first, because if you did them last, by the time we'd cut the outside, it wouldn't be there anymore, would have fell away. Right, so we'll click on here, click P, and it's now making a G code, saving as a G code, and it's called DB44 spanner. Save. Everything's alright. If it's not alright, it tells you there's problems. Okay. Right, I'll give it a quick buff up with a wire wheel on a grinder, and I'm sure you'll agree it's decent. The finish on the actual cut's fantastic. It's cut the letters out quite nicely. They could be improved by tweaking the settings, but I think for a mechanic it pisses about. That's not bad. Not bad. It's even the right size, just under 45, so he can file or grind that. But honestly, when I look at the finish on there, I could have cut that to size and it would have been perfectly acceptable. Quite pleased with that. It's got its DB on it. Like I say, that there's a little mark there. It could be improved, but one for the call outs. Once again, it's just time to say thanks for watching, thanks for subscribing, and as always a massive thanks for all the vouchers that come in. Anyway,
Thanks for watching.